I love that. That is going to be my answer to everything now. Just lead a revolution. Just go for it. And I love the way, like, because when you talk about DevOps and inner source, they often both come down to like just as much or even more so the cultural shift as opposed to a technological shift. So I think she like absolutely nailed it on the head and just I just have like I have an image now of like all these like IT companies with like little people walking around like flags like lead a revolution.
Well, that's what GitHub Satellite does.
We lead revolutions at GitHub Satellite, but enough about leading revolutions. We've got some really cool things happening for the rest of, like, I think we've got maybe a couple hours left. Oh my gosh, it's going so quick.
I know.
So would you like to give us 4 more sessions? Would you like to give us a quick taster of what those 4 sessions are going to look like?
And just a little bit more, yes. After our next session, we actually have Becca Zanstein coming on to talk about collaboration beyond the code. And after that, we're having Brian Douglas, always known as Beat Dougie, to give top 10 tips for project maintainers. So we're not done. It's still going. I'm pretty excited.
Anywhere. So much more coming. All the exciting stuff.
Yes. So, and I want to make sure everybody remembers, go to githubsatellite.com/discussions. That's where you can ask questions with Denise right now for the next 30 minutes and for all of our speakers that are coming up. But speaking of coming up, Mish, do you mind if I introduce our next speaker?
You can do the honors. Go for it.
Thank you so very much. I love doing this. Our next speaker has a background in cryptography and game theory and has this magical skill to bake without following a recipe, and it's still doing well. This person is a product manager here at GitHub, and the name of her talk is Securing the Software Supply Chain Together. Please help me introduce Maya Kaczorowski.
Awesome. Thank you so much. So today, welcome to GitHub Satellite, first of all. So happy that you could join us virtually. My name is Maya Kaczorowski, as we just introduced, and I'm a product manager working on software supply chain security at GitHub. Today, we'll be talking about what we can do together to secure the software supply chain. In our short time, we'll cover what a software supply chain is and why you should care about securing it, how GitHub helps you secure your software supply chain, and what you can do as a developer, maintainer, or researcher, and give you a quick summary of what you can do starting today. So first off, what's a supply chain? Well, it's anything that you depend on to deliver your end product. For a pharmaceutical company, it's the provenance and the verification of ingredients that go into each drug to ensure high quality. For a chocolate bar that you buy at the store, it's the list of ingredients and some information on nutritional contents, maybe organic ingredients and maybe production facilities. So then what's a software supply chain? Well, it's everything that goes into your software and where it comes from. Who wrote it, when it was contributed, how it's been reviewed for security issues, any known vulnerabilities, supported versions, license information if applicable, everything and anything. It's everything that you could need or could want to know about the software that you're running to help you determine your risk profile. So a software supply chain then is anything that goes into or affects your code from development through your CI/CD pipeline until it gets deployed into production. Why does the software supply chain matter as a concept? Well, software dependencies are pervasive. It's normal for your projects to use hundreds or even thousands of open source dependencies that you didn't write yourself. Industry data suggests that anywhere from 85 to 97% of enterprise code bases come from open source. But those are things that you depend on in your software. And if one of those dependencies has a vulnerability, then chances are that you have a vulnerability as well. Being able to leverage the work of thousands of open source developers means that thousands of strangers effectively have commit access to your production code. So an innocent mistake or a malicious attack to your supply chain can affect you deeply. Now, when we talk about your dependencies, what's scary isn't as much your internal dependencies that you develop, because hopefully you have controls in place to, say, prevent developers from pushing code from their bathtub, or you restrict it to a super admin rights. What is scary, though, are your third-party dependencies. Externally, like open source code that your developers pull in. Because although open source is easy for developers, that means that it's also easy for attackers. And I don't want to scare you. I want you to keep using open source code. I want you to keep contributing to open source code. I just want you to do it thoughtfully from a security point of view. So what kinds of software supply chain vulnerabilities are there, and do attacks actually happen? Let's start with the attacks first, because that always comes up. So unfortunately, supply chain compromises are real. We've seen quite a few attacks in recent years across many different ecosystems. There are several different methods to attack your supply chain: inserting malicious code directly into a dependency, taking over a maintainer account or a project, compromising a build tool, signing keys or distribution tool, or even typo spotting, which is when an attacker creates a malicious package with a very similar name to a known package, hoping that users accidentally download it. All of these supply chain compromises are occurring in the wild. To highlight a few examples that you might be familiar with, first, Gentoo. On June 28, 2018, maintainers of the Gentoo Linux distribution were notified that they had been removed from Gentoo's GitHub organization. An attacker had used credential stuffing, which is reusing passwords from another site somewhere else, to gain access to an administrator's account, then created a dummy admin account and removed other admins. They had also added or attempted to add malicious code to several repos to RMRF so that users running the code would delete their data accidentally. Thankfully, this was noticed by an admin within a matter of minutes due to GitHub email alerts, and within an hour, Gentoo was working with GitHub support on the issue. The attacker had tried to make 6 commits in a span of 4 hours, but these were all reverted, and it's not suspected that any end users ran the compromised code. Another example, EventStream, that you're probably familiar with. In the fall of 2018, a user volunteered to take over the EventStream project on GitHub. Though it has more than 2 million downloads, like all open source projects, it could be better supported. And so the author welcomed the extra help and even gave the newcomer publishing rights. I want to emphasize that the author is not to blame here, because we should have better ways to support these developers and also verify trust of our ecosystem. So what happened next? Well, on September 9th, 2018, the new user added a new dependency to EventStream, FlatMapStream, and then rewrote the code about a week later to actually no longer require that dependency. That removal was made in the code base, but it wasn't pushed through to where the library is hosted on NPM. Then on October 5th, another user added malware to FlatMapStream. So then anyone who built or used EventStream and pulled in the latest version of FlatMapStream would receive this malware. The malware was very specific. It targeted developers of a specific cryptocurrency wallet, the Dash Copay wallet, to try to insert malicious code in the wallet itself. This was discovered almost 2 months later, and unfortunately, the malware did make it into a handful of releases of Dash Copay before being remediated. And before you ask, no, I have no idea what was going on the summer of 2018. I don't know why there were so many attacks there. But almost all of the time, the aims of these attacks is the same. Like other security attacks, it's almost always about money. That's usually malware, to mine cryptocurrency, say, or as part of a botnet. But it might also be a backdoor to allow for future malware or data exfiltration if the package ends up in a particularly, interesting, juicy place. In some cases, an attacker could also be aiming just to disrupt the service and take it offline. Now, I often see security vendors trying to sell their products and viewpoints with fear. The sky is falling and you need this new security tool. That's really not what we're trying to do here. I want to talk about attacks because I know that I'm going to get asked about attacks, but I do not want to be fear-mongering. We're talking about these attacks to level set and educate. These attacks happen, but they are rare. We are working to help make the whole supply chain more secure. So although we see these compromises occur in the wild and we do need to address them, the reality is that most of our concerns with the software supply chain is just forgetting to patch your code. The issue in supply chain security is unpatched software. It's not open source use, and it's not software supply chain compromises. Think about it this way. If a component in your code base is open source, and it's likely that quite a bit is, as we talked about earlier, then if any of those dependencies have vulnerabilities, you are potentially affected. How can you address that issue? Thankfully, maintainers are pretty good at, maintaining. It's estimated that 85% of vulnerabilities in open source are disclosed with a patch already available. And it's your job to deploy that patch. What you want to be really, really good at is knowing when there's a new vulnerability and patching it. At the same time, developers and security teams today find this hard. And I would go even further. 52% of developers find it painful to update vulnerable components. So that's what I want to focus on today. This is something that should be easy. This is automatable, and it's something that we can make easy. So now that we understand where the issues are, making it easy for you to address known vulnerabilities and also dealing with those rare compromises, let me paint the picture for you of what GitHub is trying to do here. Our goal is for GitHub to lead and enable developers, maintainers, enterprises, and researchers in securing the world's software. We want to make consumption of open source software something that all developers can do with confidence so that they have more faith in the security of open source code than in their own code. We want to make security of open source software as automated as possible so that the community can scale to secure all software. That means a couple of things. First, it means that ensuring that the open source community has the tools that they need to securely develop and maintain open source projects. That means automation. It means not needing maintainers to invest time, which they don't have, into patch management, vulnerability reporting, CVE issuance. We want to help you. Second, it means maintainers, enterprises, and developers to provide and utilize information to decide which dependencies they want to use in their supply chain and how they want to consume these in order to minimize risk. That means knowing what you are consuming and having automated processes to use this information, reading the label and then acting on it. And thirdly, it means empowering enterprises to understand and control what code, binaries, and packages they use based on their security, privacy, licensing, and audit requirements, letting you make decisions that work for your business and with your requirements. And that's where we're headed. That's how we're going to tackle the issues that we see in software supply chain today. And we're just a couple of steps along that journey right now. So in delivering on that vision, we need to make sure that our tools work for all users. That means making sure GitHub software supply chain security tools are great for a few specific sets of people. Developers, and that includes enterprise security teams, maintainers, and security researchers. Let's talk about developers first, because, well, GitHub puts developers first. As a developer, you want to know what dependencies you use, know about vulnerabilities in those dependencies, patch them, and then get back to work. When you hear about a new vuln on Hacker News or Twitter, you're like, damn, I didn't want to be doing that today. I'm busy. I have to go feed my sourdough starter later. So how does GitHub help you? Well, first, to know what dependencies you have, use Dependency Graph. Dependency Graph identifies all upstream dependencies and public downstream dependents of a repository or package. You can see your project's dependencies and some of their properties, like vulnerability information. To generate this information, Dependency Graph needs read-only access to a repository to access information on explicit declared dependencies, which is a standard format for each ecosystem. For example, package.json files for NPM. We parse all known package manifest files in a user's repository and then use this to construct a graph with known dependency names and versions. Items are added to Dependency Graph basically when you add a new dependency. That is, when you push a change to the default branch that changes the manifest file for that repo. Dependency Graph is on for public repos by default, but must be enabled for private repos. If you enable it for private repos, then the owner of any of your dependencies doesn't see that info. It's one-way visibility. And if you're using GitHub Enterprise Edition, you also have access to Dependency Insights, where your organization can view the summary of their dependencies and vulnerabilities across repositories. So now that you have information about your dependencies, you have time to feed your sourdough starter. That's great. But tonight was a big night. I was going to cut my hair. So how do I know if I actually need to apply a patch? Well, once you know about your dependencies, you want to know when they have new vulnerabilities. You can do this with security alerts for vulnerable dependencies. You'll be alerted when your repo has a newly discovered vulnerability. To do this, GitHub compares the information in the dependency graph to the information in GitHub's advisory database, which I'll talk about in a few minutes. A security alert can either be sent when any push happens to the default branch that contains a manifest file. That is, you added a new dependency, and so we check any vulnerabilities in that dependency. Or when a new vulnerability record is added to the database. That is, a new vulnerability is discovered, so we alert any repositories that are vulnerable. The alert is sent to repo owners by default. This takes into account versions. So if you're running a newer version of a dependency that's already been patched, then we won't bother you. Similarly, security alerts are on by default for public repos, but you need to opt in and enable these for private repos. And with that, you know about your dependencies and you know that they're vulnerable, so you can take a break tonight and cut your hair. But wait, you still need to actually apply the patch. I mean, as a developer, I actually have to code. This is terrible. I was going to watch Tiger King tonight. Thankfully, we made this easy for you too. Dependabot will send you a pull request to update a dependency to the minimum version that resolves a known vulnerability. This is done automatically based on known vulnerabilities and known patched versions. Dependabot security updates create a pull request to update package dependencies in a lock file by proposing a change to the lock file. When I say the minimum change, I mean that it's the first version with the patch, because a small change is easier for you to review and easier to merge. And we want you to keep moving forward. In fact, once you turn on Dependency Graph and security alerts, then Dependabot security updates are automatically enabled. Easy. And that really is so easy. You can review it, review the pull request, check the test results or your CI/CD results that you have for that pull request, and then make the fix, and then get back to Tiger King, you cool cats and kittens. And we've seen a lot of you use this. Since Dependabot security updates were integrated into GitHub natively, we've generated and seen you merge a ton of PRs, over 750,000 PRs, in fact, and over 4 million total, including Dependabot preview. We're glad that we can make patching easier for you. We've also seen anecdotally, when we had an error in generating Dependabot PRs, which thankfully is now fixed, that when you receive a PR, you're almost twice as likely to patch it within a day and 1.5 times more likely to patch within a week than when you don't receive a PR. And that's super critical. In fact, for repos that have Dependabot security updates enabled since GA, the mean time to repair, MTTR, is only 40 days. Now, that sounds, good or bad. How do I know? Well, fortunately or unfortunately, I can't compare this to repos without these features enabled on GitHub, because we respect your privacy. And if you don't turn the feature on, then we don't know about your vulnerabilities. So I have to compare to industry metrics. The industry says that this currently takes months. Sonatype says that MTTR for time from vuln disclosure to patch in a project is 180 days. And Snyk finds this for open source projects to be more than 2 years. Getting your repo down to just 40 days is a huge improvement. Unfortunately, today, we can't always generate a PR for you, and we're working on this. We're continuing to invest here in the ecosystem coverage for alerts and PRs, and making it easier to review, test, and merge these PRs. And since acquiring Dependabot a year ago, we're continuing to add functionality into the core GitHub product. Look out soon for Dependabot version updates, which will send you a pull request to update a dependency to the latest stable version. You're already familiar with this functionality if you were a Dependabot user prior to the GitHub acquisition, but this will be new to GitHub native Dependabot. And this helps improve your security as well, right? When a really critical bug hits, you need to be able to quickly patch. In general, patches will only come out for the latest supported versions of a dependency. And so regularly updating your dependencies means that a change will be relatively minor, and so it's less likely to break. All right, so we talked about developers. Now let's talk about maintainers. You also have a critical role in keeping the software supply chain secure, and that's properly disclosing when you find a new vulnerability in your project and patching it. When you find a new vulnerability in your project, you can create a security advisory to develop and publish the fix. In a private draft advisory and in a private fork, you can discuss and fix your issue, and then publish information when you're ready to go public, like once you've developed a fix. If applicable, maintainers can also request a CVE directly from GitHub for their vulnerability. Vulnerabilities are published to GitHub's advisory database, which is an open source database of vulnerabilities for several ecosystems supported on GitHub. It's licensed under Creative Commons 4.0, so it's free to use with attribution, because we think that this data should be free and easily accessible so that anyone can use it to verify and patch their code. The GitHub advisory database is what powers our features like security alerts for vulnerable dependencies and the Dependabot security updates. How do you even know if you have a vulnerability, though? Well, you might find it using a tool like code scanning, which was talked about in the keynote this morning. And if you're lucky, a researcher or community member reports issues directly to you. Now, let me tell you the number one pain point of security researchers today. It's not knowing who to go to with a vulnerability. It's trying to do the right thing and having no way to do it. So many researchers that I know who chose to go public with a 0-day, which is a vulnerability without a patch available, it's because they tried to contact maintainers and got no response. In the 2019 State of Open Source Security report from Snyk, they found that if you had a disclosure policy, 73% of incoming reports would be private. And if you didn't, only 21% would. That's people bashing their heads against a wall, trying to help you and trying to do the right thing. So what do? It's actually surprisingly straightforward. Lay out your security disclosure and reporting policy in a security.md markdown file for your repo. This describes everything researchers and users need to report a potential vulnerability. For example, you might include a security email account. You can create per project policies or automatically apply one security policy to every repository in an organization. If I could wave a magic wand and make all maintainers do something to improve their security, well, this is actually not it, it's 2FA, but this is a very close second. So please consider adding a security markdown file to state your disclosure policy. And if you're a researcher and you find a vulnerability in an open source repo, back me up here. Go check out that security MD file and see what you find. To make this even easier, when you're filing an issue in a repo, say about a vulnerability, if the repo has a security policy, it's surfaced to you right in that reporting flow. Click through to check out the security.md file and the recommended way to report an issue. Even if not, please try to report the vulnerability privately to other contacts that you find online. And soon, we'll make it easier for you to get recognition for the work that you do. As part of security advisories, maintainers can credit anyone who helped discover the issue or develop a fix as part of the advisory. These will show up as part of the vulnerabilities published in the advisory database. Thank you for the ongoing work that you do to support the security of our open source code. So let's do a demo. We'll recap what we talked about today and what developers can do. We will create a new private repo. We'll enable dependency graph, security alerts for vulnerable dependencies, and dependent security updates. Then we'll commit a package manifest file and watch the magic happen. We'll be able to see our dependencies, be notified of vulnerable dependencies, and receive PRs to fix those dependencies, and then patch. And you'll see, too bad there aren't commercial breaks anymore, because you could do this all in this commercial break for Tiger King. So first, I'm in my organization here, and I am going to create a new repo. And my Satellite demo, great. And I'm going to create a private repo because, like I said, these features are enabled for public repos by default. So we specifically want to see what it looks like on private repos. I create a new private repo. And now that I have that going, the first thing I'm going to do is commit a manifest file in my repo. So I'm using Java. So I'm committing a project object manifest file, which I always thought was a funny word to say. I have a bunch of dependencies specified in that. I'm a great developer. I'm committing straight to master. Please don't be like me. Okay, let's go over to the security tab. In the security tab, you'll see the new way of enabling a bunch of features that we talked about earlier today in Gray's talk. And one of these items is dependency alerts. So we're going to go ahead and click on that. And first, I'll allow GitHub to perform read-only access. This is to access the actual contents of the package manifest file. And then I'll enable dependency graph and security alerts. And those little green check marks means that I'm good to go. And as I mentioned earlier, once you enable dependency graph and security alerts, then dependent security updates are also enabled by default. So let's go over into Insights. And I'll click on dependency graph. And I should see all my dependencies right here. So what's in that package manifest file includes XMP core, Android SVG, Jackson databind, etc. And so I understand what all my dependencies are. And you'll see, just in that time that I committed and enabled that functionality, it's already discovered some known security vulnerabilities. And some of those, aren't looking great. So let's go see those security alerts that I have. So in my security alerts, it tells me that I have 5 open security alerts. And wow, one of them is critical. Let's click on that one. So this tells me that my security alert is in Jackson databind. It tells me how to remediate my the vulnerability that I have here. I need to update to a later version. And it tells me which CVEs this is related to. And there are a lot of them, a lot of moderates and criticals and highs. This is not looking good. And so I need to update this and actually apply the fix. And thankfully, you'll see right at the top here, Dependabot has actually already opened a pull request. So let's click on that. Dependabot has opened a pull request to upgrade my upgrade my dependency to a no longer vulnerable version. It says that it fixes the security vulnerability. And in the package manifest file, it moves it from 2.8.11 to 2.9.10.4. So if I had some CI/CD checks, they might run here. I'm good to go. I'm going to merge that. Thank you, Dependabot, for fixing the issues that I have there. And you'll see that that security vulnerability is gone because we fixed it. Great. So to quickly recap that, what do? We created a new repo, we enabled some features, and then you saw within a matter of minutes that we actually had a pull request to fix issues in your project. Minutes. That was awesome. Okay, looking across how vulnerabilities are discovered and remediated then, for security researchers, what does GitHub do? For security researchers, once you identify a vulnerability, please report it. Check the security.md file if the repo has one to understand their vulnerability reporting policy. For maintainer, make sure that you have a security MD file with your policy. If there's one thing you can do right away, it's this. Well, and enable 2FA. Then, if or when you receive information about a new vulnerability in your project, you can privately discuss and create a fix, and then publish a security advisory detailing information about the vulnerability. And soon, give credit where credit is due to those that helped discover the vulnerability or develop the fix. For developers, you want to know what dependencies you use, want to know about the vulnerabilities on those dependencies, patch them, and then get back to work. Dependency graph helps you understand your project's dependencies. Security alerts for vulnerable dependencies let you know when one of those contains a vulnerability, and Dependabot Security Updates sends you a pull request to automatically suggest an update to a fixed version. And soon, you'll be able to use Dependabot version updates to keep your dependencies up to date on an ongoing basis. And if there's one thing that you do today, it's enable these features for your private repos. They're already on for your public repos by default, but please go into your settings and enable them for any private repos that you manage. And there are lots of other capabilities that GitHub offers in the security space that we didn't talk about here, primarily to help you discover new vulnerabilities in code. Code scanning uses CodeQL, a semantic code analysis engine to query code for potential vulnerability patterns. And secret scanning revokes secrets that you've committed to public repos and alerts you of secrets in code in your private repos. So altogether, you can use a suite of GitHub security features to help secure your code throughout your development lifecycle. To learn more, check out GitHub's overview of security features at the link below. Thank you. Looking forward to Q&A.
Woo! Thank you so much for that wonderful presentation, Maya. I also love the way you just dropped in all the things that people are doing in isolation, like feeding their sourdough starter, cutting their own hair, and watching Tiger King. I'm just like, that is just going to resonate with so many people. And you don't need to cut your hair, Jared. You're fine. Just get the brush.
Are you kidding me? She told me to cut my hair.
On camera. I love
it's funny seeing how many pubbers cut their hair like this weekend or something for this presentation. Like you're seeing all my colleagues that have fresh new haircuts.
Oh, just sit at myself, while all my security vulnerabilities are being fixed automatically. Love it. So good. Now we have a couple of questions coming through from the discussions. I probably have time for maybe one or two questions. Jared, what have we got?
Yeah, and I just need to say, I'm not cutting my hair. If I cut my hair, it looked like I jumped into a lawnmower. So I'm going to leave that to you who are more skilled. But going to the questions, we have from GA Beach. Are there plans to expose an API endpoint to check if vulnerability alerts are enabled on a repo?
Ooh, to check, I see that just whether or not it's enabled. Yeah, that's really something that we're looking into. I know that being able to manage all of this information via API endpoints and webhooks is something that we want to make really easy for you, because I know a lot of you have built custom tooling on top of this. So that's certainly part of what we'd like to do.
That's awesome. I think they're going to be super excited for that. So I think we got time for a couple more. I think so. So next question.
Good time.
What does the dependency graph use to determine my dependencies?
The dependency graph looks at a couple of different things. It primarily looks at your lock files to determine your dependencies, and it also takes into account transitive dependencies. So if your dependencies have other dependencies, then it looks at those as well. So we look at the versions that you specifically include in your lock file package manifest files to determine what you're using.
Outstanding. Okay, I think we have time for one more, and then maybe we can get your last tip, Maya. All right, last question. If I find a vulnerability in a GitHub project, but I'm not the maintainer, can I publish a security advisory?
You cannot today. We want to make those. We would like you to talk to the maintainers directly and figure out how to create the fix and the advisory. Although we hear you, we get this request a lot. And so it's something we're definitely thinking about doing in the future.
Outstanding.
Talk to the maintainers. They're nice people. They're not going to bite, right? Now, apart from cutting your own hair, watching Tiger King, and feeding your sourdough starter, what is your number one top takeaway tip for this, Maya?
Not even related to my presentation, but enable 2FA. So many supply chain compromises come from account takeovers. If you all enable 2FA, I might be out of a job.
Please.
Okay, so every single person out there watching right now, go enable 2FA. Look, we love you, Maya, so you're not going to be out of a job, I don't think. We'll find some cool things. So you can just bake cool things for us and cut everyone's hair. It'd be great. So I think it'd be fine. But enable 2FA, and then thank you so much for joining us and offering up all your advice and expertise. Maya's going to be over in the discussions for the next half an hour. Thanks, Maya.
Thank you, Maya.
Thank you.